Welcome back for some notes over solving radical equations. One thing I'm going to say before I even get started on the actual examples is there are several different types. If you read the little titles at the top, this will kind of lead you to which sections of your homework go over these. Um, One thing that I'm going to say before we start, and this is the most important thing for the entire assignment, is if there is only one radical. So what I mean by that is this has one square root, this has one cube root, not these because these have two, but then again on the bottom. You have to absolutely isolate the radical first. Somebody somewhere is going to get confused on a problem, and it's going to be because they didn't do this first. What I mean by this is you want to get rid of this, so the only thing left on this side is the square root. So I want to subtract this 5 to the other side. Now, the reason why that's so important is because now I just want you to think of this as solving a regular equation. Don't get caught up in the fact that these look confusing, because now the issue is we need a way to get rid of the square root. The opposite of a square root is the squared power. So if I square this side, it is going to get rid of the square root, and that's just going to be x plus 1, no square root. But I can't just square that side, I need to square this side as well. So we've never really done this before, but it is possible to give both sides a power of 2, the same way as it is possible to subtract 5 from both sides. The only issue is if I had tried to square it here, I would have had to multiply this whole thing by itself, which would have been this. And that looks like an absolute headache. So we're not going to do that. That's why we just got rid of the 5 first. Because then there's just one thing over here and one thing over here. And then 11 squared is 121. And to finish off this equation, you need to subtract that 1 to the other side, leaving your answer as 120. These equations are way easier than they look. You just have to make sure you do this first. Number 2 is a little difficult because this is kind of hard to see. So you could, right now, cube everything to get rid of the cube root, or take everything to a power of 3. But instead of doing that to the 7 and the 84, divide this side by 7 first, so that now it is 12. And then what you're going to want to do next is take both sides to the power of 3. Let me type this in really quick. So the cube root and the power of 3 cancel, and you just have 5x minus 7 equals 12 to the third power, which is 1,728. I know, it's kind of crazy. Then you have 2 steps left to solve this equation. You need to add the 7 to the other side, which is 1,735. And then you're going to divide by 5. Which is 347. And that's your answer. Now, let's talk about what happens if you do happen to have two different radicals. So, this gets a little funky because there's really nothing outside except for this 3, and it's just going to stay where it's at for right now. You're going to do the same thing. You just don't have to isolate it first. So, I want to square both sides so that the square roots both go away. Now, the only thing that's kind of tricky about this is over here on the right side, I have to square the square root, and I have to square this 3 in front. Whereas on the left side, I only have to square the square root because that's the only thing over there. So that's just going to become 7x plus 2. I think of the radical like a shield, and this is the chemical that breaks down the shield. So now it's just gotten rid of the shield around the 7x plus 2. And over here, the 3x minus 2 is going to stay the same because it had the shield on it. So the shield just isn't there anymore. But that 3 was outside, so it actually has to get squared. And 3 squared is 9. Then, I'm going to take that 9 on the right side, and I'm going to multiply it to that whole side. Distribute, like this. Then I need to solve this equation. So what I'm going to do is subtract 27x from both sides, because I like for my x's to end up on the left. 7 minus 27 is negative 20x, plus 2 equals negative 18. And yeah, there's a couple of steps on this one. It's a little annoying. Now we need to subtract that 2 to the other side. Again, your whole goal is to get x all by itself. Negative 18 minus 2 is negative 20. And then you just divide by negative 20 at the end. And believe it or not, this crazy looking equation ends up having the answer of 1. So that gobbledygook right there is only true if x equals 1. I know, it seems insane. Same kind of thing is going to happen on number 4, but it's not a square root anymore, it's a cube root. Attention to detail is going to be really key for you on this assignment because we need to take both sides to the power of 3. Right, but over here, that just sort of gets rid of the shield, as I'm calling it, the radical. And over here, since that 2 is outside, you actually have to take it to the third power. And 2 to the third power is 8, and then you keep your x minus 1, but now it doesn't have a cube root around it. And then you take that 8 and you multiply it through. And you're going to solve this equation the same way we did the other one. I'm going to minus this 8x to the other side. 1x minus 8x is negative 7x plus 6 equals negative 8. Then I need to subtract 6 from both sides. Negative 7x equals negative 14. And negative 14 divided by negative 7 is 2. If you are having trouble solving the equation after you get rid of the radicals, come see me because that is something that we've talked about a while ago. You might just need some helpful reminders. And now we're upon the last, second to last section, rational exponents. Remember this from the first half of the unit. This 1/3 power right here just means that this is the cube root of 5x plus 7 equals 3. Or you don't want that 1/3 out there, so we want to figure out what we can multiply by to get the power back to 1, because a power of 1 doesn't actually have to be there. So we would multiply by 3 and give each side an exponent of 3. Or you can think of it like this, and you would do the same thing. The cube power gets rid of the cube root, but this is why the cube power gets rid of the cube root, and why the cube root is the 1/3 power, because a power of 3 multiplies together, and that's just 5x plus 7 to the first power, which you don't need to write. And then on the other side, 3 cubed is 27. And then you would subtract 7 to the other side and divide by 5. So don't freak out when you see these rational exponents. They're really the same thing as they were in the last half of the unit, which we already took a quiz over and everything. So if you're still having trouble with those, let me know. Okay, so I'm subtracting the 7. That gives me 5x equals 20. Hopefully you know that that means x equals 4. Either you divide by 5 on both sides, or you're asking yourself 5 times what equals 20. All right, same thing on this next one, but we have a 1/2 power, so I need to square both sides to get rid of that 1/2 power. So that now these multiply to 1, and this side is just 4x plus 8. Right? Or cross out the 1/2, think of this like a square root, and then you're doing the same thing. But be very careful over here on the left side because you have to square both of those. So it's going to be 2 squared, which is 4, and x squared, which is x squared. Now, what happens when you get a question like this is you have an x squared now. So we've got to get everything onto the same side, which means I'm going to minus this 4x and I'm going to minus this 8 over here. So that it's 4x squared minus 4x minus 8 equals 0. And the only way to solve something that has an x squared, an x, and a number at the end is factoring. I know everybody is super pumped that factoring is back. But before we start, what I'm going to do is divide this entire equation by 4. You can only do this if it has an equal sign. It already equals 0, so we're fine there. 4x squared divided by 4 is just x squared. Negative 4x divided by 4 is just negative x. And negative 8 divided by 4 is negative 2. 0 divided by 4 is 0. So only if it's an equation can you divide them all by something. Now, back to our factoring skills, we want this to be set up into 2 parentheses. And we want to find the two numbers that multiply to negative 2. We want to pick the ones that add to negative 1 here in the middle. That's going to be 1 plus negative 2 to make negative 1. And then, again, this is a bit of a throwback. Once you have your factors, you want to set each one equal to 0. Most of you don't write this step anymore, though, because all you're going to do now is the opposite of this. So it's going to be negative 1 and 2. And then what you need to do is take these two numbers and make sure that whatever was underneath the square root was positive. So 4 times negative 1 is negative 4 plus 8. That's going to be a positive number, so we're fine. 4 times 2 is 8 plus 8 is 16. We're good to go there too. All right, checking for extraneous solutions. So this is just a regular equation. I'm just going to note that we have to square this side to get rid of it. And when we go to square this side, we're going to have to multiply all of that together. So we're going to have to do 5 minus x times 5 minus x. And over here, it's just going to be negative 3x plus 33. And then we've got 25. 5 times negative x is negative 5x. Negative x times 5 is negative 5x. And negative x times negative x is positive. 2 negatives multiply to a positive, x squared. And then I'm going to want to get all of this on the same side. This together right here makes negative 10x. They do not cancel because they're both negative. And just like I did on this one, I'm going to want to get everything on the same side. So what I'm going to do is write my x squared first, minus 10x plus 25. So all I've done is I've rewritten this side right here correctly, and then I'm going to write the other side on the other side. So I am kind of flipping it around a little bit because I want my x squared to go in front. Then I didn't change anything here, but I wrote it on this side. I'm going to add my 3x and subtract the 33. Just make sure you do the opposite of both of them. Okay? Now, you are looking for two numbers that multiply to -8 and add to -7. Okay? So -1 plus 8 is 7. We want it to be -7, so we switch the negative to the 8 instead. Okay, so we get two answers. This one's going to be -1. This one's going to be 8. If you need to see why, look at the number 6 again. What you need to do is make sure that both of these are going to work in your answer. So I'm going to check -1 first. This is going to be the square root of -3 times -1 plus 33 equals 5 minus -1. So I'm taking the original equation before I did anything. So this is going to be 3 plus 33, which is 36. And this is going to be 5 plus 1. Okay, so we get square root of 36 is 6 equals 6. That one checks out, it's fine. And then I do the same thing with the 8. So that's going to be -24 plus 33. -24 plus 33 is 11. And then, sorry, it's definitely 9, not 11. There we go. 5 minus 8 is -3. Here's the issue. The square root of 9 is 3, but this side is -3. So that's not true. So what we do for our answer is we say that it's -1, comma, 8 is extraneous. Extraneous means it was a solution when you solved it, but it doesn't work when you plug it back in. I'm going to come back up here to this one. I didn't check these very well before, but I'm just going to say this. If I plug in -1, I get 2 times -1 equals the square root of 4 times -1 plus 8. This is -2 equals the square root of -4 plus 8 is 4. The square root of 4 is not -2, so this one was also extraneous. Anytime you get two answers, check them both to make sure they both work. I'm going to come up here again and check 2. So I'm going to have 2 times 2 equals the square root of 4 times 2 plus 8. So this is 4 equals 4 times 2 is 8 plus 8 is 16. Yeah, the square root of 4 equals 16, or square root of 16 equals 4, sorry. So that one's fine. When it says checking for extraneous solutions, don't check these on every single problem, just do it on the problems that I say this on. Take your two answers and plug them back in to make sure that this equals this, okay?